artificial Kuramoto oscillatory neurons, AC or N, are a type of artificial neuron that work differently from traditional ones. Instead of just turning on or off like a light switch, they are designed to oscillate, which means they go through a repeating cycle like a pendulum swinging back and forth. Here's a breakdown of how AK or N works, explained in simpler terms. Oscillating neurons. Each AK or N is represented by a vector that rotates on a sphere. Think of it like a point moving around the surface of a ball. This rotation is not random. It's influenced by other neurons it is connected to. The Kuramoto model. The way these neurons influence each other is based on the Kuramoto model. This model describes how oscillators, things that repeat a cycle, tend to synchronize with each other. Imagine lots of pendulums that start swinging together as if they are connected. In AC or N, this means that connected neurons try to align or oppose their rotations, creating synchronized patterns. Synchronization and binding. When neurons synchronize, they are said to be bound together. This binding allows the network to compress information. Instead of separate neurons for each detail, like color, shape, and size, synchronized neurons can represent more abstract concepts like a blue square toy. How the neurons update. Each AK or NTKS rotation is affected by a few things. Black small square connected oscillators. The rotations of other connected AK or NTKS influence its rotation via connections represented by weights. If the weight is positive, the connected oscillators align with each other. If negative, they oppose each other. Black small square conditional stimuli. The AK or NTKS are also influenced by input data or the outputs of previous layers of the network. This input is a biased direction that tries to pull the neuron's rotation in a certain way. Black small square natural frequency. Each AK or N has a natural frequency that determines its own rotation speed and direction. The neurons are updated over time through a mathematical formula that combines these influences and ensures that the vectors stay on the sphere. This is called a Kuramoto update. Network structure. These AK or NTKS can be used in various types of neural network layers, like convolutional and attention layers. A typical AK or N network contains multiple iterative blocks, each with a Kuramoto layer, where the neurons update, and a readout module that extracts features from the neuron states. Reasoning. The model's ability to synchronize and adjust its patterns allows it to do a form of reasoning. This is demonstrated through solving Sudoku puzzles, where the neurons' interactions lead to the correct solution. Key advantages. Feature binding. The synchronization mechanism enables the model to bind features together to create high-level representations. Reasoning. The model exhibits some reasoning capabilities. Robustness. The model is more resilient against adversarial and natural corruptions, meaning it is less likely to be fooled by changes in the data. Uncertainty estimation. The model is well calibrated, so its confidence in its predictions aligns with the actual accuracy. In short, AK or N uses the principle of synchronization to create a neural network that can learn complex features, do some reasoning, and be robust to outside interference. The combination of oscillating neurons, the Kuramoto model, and iterative updates allows the network to dynamically adjust its internal representation of data and makes it effective in tasks such as object discovery, puzzle solving, and image classification.